Alright, in this video I'm going to show you how to use armatures in Blender to animate and to, let's say, rig objects through essentially parenting. Say that you have a subject like this, it's a mechanical robot. I would like to animate it with inverse kinematic and with an armature, but obviously the robot will not deform according to these bones. So there is, I have to figure out another way to do so, and there is a way to do that, basically parenting individual pieces of the body to individual bones, often maintaining a certain offset or a certain rotation. This is I guess, the simplest way to do it. There are a bit more advanced technique for more like complex, I guess, mechanical contraptions, but let's just start with that. So first I will have to create an armature, and well, first I set up my pieces as separate meshes. I named them differently, and by the way, you could potentially just parent them, assuming that you have the correct origin. In this case, I actually put the origins sort of like where I want the rotations to be, but it's not really necessary, I think, if we are using bones. But let's say that I could do something like this: parent, select two objects, and the active one can become the parent, and now I can basically like move one object and then move the other, and then I can parent this other here, and then they will sort of like follow. Oops, I badly selected something here, but yeah. So I could do something like this that allows me to essentially like create an articulate robot and animate it through rotations. But that will be too easy, and that will be not as easy to animate, let's say that, because there are some advantages that come with the using an armature, using bones. So let's try to do that in the proper way. So I'm going to first create an object armature. The object armature will be created, like all new objects, where the origin cursor is. So I'm actually gonna, before creating it, I undo that. I'm gonna move the 3D cursor to the center of the base of my first object here. So cursor to selected, and that snaps it there. And now I can create, in object mode, I can create the armature. Note that the armature is, at this point, is just separated from the main robot parts. And that's kind of like how I like to do it. Maybe there are other ways, but if you go to view, like right now, I don't see my armature unless I go to some kind of X-ray, and it's a feature, but sometimes it can be annoying. And so here, with the armature selected, you can go to viewport display and select in front. In front will make the bones always visible. You can also make them less conspicuous, for example, as wire. The octahedral bones are probably the best ones, because they give you a sense of where the origin is and a sense of the orientation and so on. So let's use those for now. Now with the armature on, armature selected, I can go to edit mode and change the individual parts of my armature. Right now I have to select to be in bounding box selection, otherwise it doesn't quite let me select the various parts of each bone. So the bone is basically goes from point A to point B. I'm going to move it using some kind of like snapping. I'm gonna try to snap it to the vertex, and I'm gonna try to snap the end at the where I want the rotation to be. Right now my robot is not perfectly aligned. I kind of like purchased it like that. It seems pretty good, but it's not perfect, and your robots will not be perfect either. So I'm gonna just like snap it to the center of rotation of the part that is going to rotate, like this. And that's kind of important. The position might not be really that important, and you'll see that in a second. Then I'm gonna kind of like do the same, creating a bone for the second piece for the second articulation. And in edit mode, again, like editing the armature, I can extrude a bone. Extruding means create a connected bone here. And I can stick it sort of like also at the end of the rotation. Actually, I think I'm gonna want to put it on the axis of the following one. I think it will be probably better for me. Okay, so it's there. And note how the bones in Blender, in any 3D modeling, are not really functioning as bones. They're not providing support. The bones can actually exist, since they are invisible, they can exist outside of your object, outside of your mesh, especially if they are not meant to deform anything. In this case, my robot is shaped like this. This is how certain industrial robots are made. And I don't have to sort of like follow through that. I mean, I could make another bone that has, let's go to edit mode and so on. Like nothing prevents me from having in a single bone and then sort of like moving it, like here, for example, and then parent the bone to the same root, to the root here, so they will maintain the same distance. But I might have some issues because the bones will not be exactly connected, and I will not be able to use the automatic inverse kinematic, which is one of the things that I like the most about sort of like using this sort of like technique. And you'll see what the inverse kinematic is. Basically, you can have a skeleton with not connected bones, but for my understanding, it will not work. The auto IK will not work for bones that are not connected. So, long digression. Let's go back to creating bones like this. All right, so the next one will be rotated here. So I want to probably visualize that, and I'm going to go to edit mode again and extrude again, and then move the final part here, and that's it. And then I'm going to, let me make sure, yeah, that's the part that rotates, and then I'm going to extrude it once again. Oops, redo. I'm going to, I changed the bone size. I don't even know what that is. And then I'm gonna extrude it once again and put it here. And right now it's all in the same, I'm already thinking that my robot will move all in the same sort of like plane. Although this model of robot might even rotate here, but the object is not even separated, so I'm not even sure about that. Anyway, for my purpose, for my animation, I just need that movement there. So, okay, now the bones should be, like, you can test the armature parenting to make sure that everything is right by switching in pose mode. Pose mode highlights the bone in blue. So there is a big difference between pose mode and edit mode. The edit mode is when you want to change permanently change the nature, the proportions of your skeleton, the parenting of your skeleton. Pose mode is mostly for animation, but for some reason it's also for parenting. So now I can sort of like see that the bones are properly parented, they are connected, so it shouldn't be an issue. By the way, I think I can already try the inverse kinematic maybe. Let's see. So yeah, so if you are in pose mode and in selecting an armature, you can go to Tool, select Auto IK, Automatic Inverse Kinematic, and then you can, instead of rotating each object, you can trust Blender to kind of like arrange your sort of like essentially change the rotation of your articulation based on the position, which is what usually happens, or what is it's very useful to have. it's very useful to have an endpoint to your animation. For example, like your hand is reaching something, or your hand is holding a sword or something, and you want to animate the trajectory of the sword more than the individual rotation of your elbow. So that's what inverse kinematics is. You're starting from a point and asking the computer to calculate the relative positions or the more appropriate position based on certain constraint. The automatic version of it allows you to do that by just clicking a checkbox, and Blender sort of like figures it out, and it sort of like works for many cases, I would say most cases. But there might be a situation in which, you know, for example, like you want to, I don't know, maybe keep this fixed or something, and in that case you have to add some constraints to each bone, and the constraints are essentially modifiers. Bone constraint properties are, yeah, basically like similar to modifier, and so you can create more like mechanism that work properly and follow certain rules of physics or certain rules of mechanics. For example, you can say, oh, this particular articulation can only move at 180 degrees, and after that it will stop, it will not bend backwards or something like that. So if you're lucky, the auto IK should work for your purpose. Now, obviously, the skeleton works, the armature works, but the pieces are not parented yet, and that's the part that sort of like the little workflow that I want to show you, which is counterintuitive at first. Basically, you want to be able to select both one individual bone and the object that you want to parent to that bone. And you do that by doing this. You go to, I think, let's see if I remember. You select the object you want to parent, the skeleton, the armature, sorry. And then you move to pose mode. The active object is the armature, so you should have pose mode available. And then you shift select the bone that you want to be the parent of the object that is currently remaining selected. Once again, you have to make sure that your viewport display is showing the bones in the front, otherwise it will be very difficult to you. Now, with these two objects selected, active object, blue, parenting object you have to parent in orange, you can go to pose and parent to the bone. Sometimes the object might move, and you might want to keep the transform, so to keep the object exactly where it is. Right now, the origin of the object and the origin of the bone are in the same place, so it should not snap away. And then as soon as you do that, it's parented, and you can already essentially try it because you are in pose mode. So you can see if by moving the bone, well, right now I'm sort of like still having that thing selected, but right now, but moving the bone, you can see that it's moving the object. Right now I kind of like forgot to unparent this thing, so that should not work. That should not be the case. Okay, so not right now. All the object I want to move are in the same hierarchy, and they are now the base has become parented to the armature. That's exactly what I'm doing. I'm basically parenting this object to this other object, even though they are belonging to two different sort of like entities. I'm going to do the same thing for the second articulation here. So select the object you want to parent first, the armature later, second, and then you move to pose mode and you shift select the bone. Then you go to pose, parent, bone, and here too you want to keep the transform. Probably, I don't know, maybe there are some cases in which you don't want to keep the transform, but in my case, since the robot is already sort of like set up, so I'm gonna do the same thing here. So 1, 2, pose, shift select, pose, bone, parent, and bone, And by the way, here you can already see what happens. You can really like make sure that the parenting works. Right now I'm just rotating it like that, but nothing prevents you from actually creating an articulation that rotates always, obviously. That's just a matter of how you want to animate it. And finally, I'm going to select, go back to object mode, select this one, that one, pose mode, pose parent bone, and keep the transform, and I should be good. By the way, this kind of parenting doesn't prevent you from parenting also this other parts. For example, the tip here, I'm planning on animating it in a procedural way in a game that was gonna go like back and forth or something like that. So this one is just parented to the main object. So right now I can go to pose mode, and with the auto IK on, I can sort of like move it around, and you can sort of like, maybe I should probably, yeah, well, yeah, I can sort of like move it around, and if I, you know, if I try to stretch it, you know, too much, obviously it might not work for some extreme case, but in general, it seems like it's moving pretty well. Now you see that there is a problem here due to the fact that I don't want the base of the robot to move as part of the automatic inverse kinematic. I would like this to be firm there. And if that's the case, I mean, there are a few solutions. I guess I could go to the relations and sort of like unparent the bone, maybe. Or I could go to inverse kinematics here and lock all the transforms here, and hopefully I will be able to move this properly. So I went to inverse kinematic of the last bone, or actually the first bone, and sort of like I excluded it from the chain. And now I can essentially animate the whole chain by just moving the position of my last bone. Now, the more, this is with the auto IK, automatic inverse kinematic. The proper way to animate a complex mechanism will be to use a constraint. I'm going to show you just how that will work, you know, for perhaps a more complex thing. I'm basically trying to do the same thing as now, but with a little bit more control. So say, for example, I don't want this bone to move ever, and so I can go to bone constraints in pose mode, I guess, because that's the mode that allows me to select a thing, and I can be like, limit the rotation, the low rotation. So I can be like, limit the X, and I'm going to set a constraint like this. I wish my bone was actually at 90 degrees, but it's actually not. So I'm going to eyeball it. It looks like fine now. So 101, and oops. I should probably modify the minimum here, or the maximum. 90. Yeah, it is slightly, okay, I think it's 91 or 0.2 or something like that, actually 91 maybe. That's because I position my bone not exactly orthogonal to the ground, but okay, and then I can constrain the rotation like this. So now the auto IK will still move the object, but as soon as I release my bone, it should snap in the constraint, which is really not great because it's basically the automatic inverse kinematic doesn't work very well with bone constraints. So we can do something better though. We can go to the bone constraint here, add a bone constraint, and have an IK constraint, which is somewhere here. Where is it? spline lock track. It is inverse kinematic. I was looking for IK, but inverse kinematic. And then the inverse kinematic is the same thing as before. I just have to select a target. I'm going to create an empty object. I'm going to put the empty object here, and I'm going to now select the IK here. Just making sure that I'm only applying it to the object mode, pose mode, just making sure that this is the bone that is being selected. Yeah, it was that. So I select the target, and now I'm basically doing the same thing as I was doing before. In object mode, I can just target the position of this object here, of this empty object. Now, with this bone constraint, I can actually do a few other things. I can, for example, exclude the last bone from the chain length. So I can do something like that, 2 and 3, and now only the 3, the 1, 2, and 3 bones from the current bone will be part of the chain. So you can do pretty complex, robotic things or mechanical things, but also you can use that, to use this kind of stuff to use, for example, like set props have your characters manipulate props and pick up objects from the ground and things like that. So there are many reasons why you might want to parent bones and use this kind of constraint. I imagine this to be useful also for things like animating cloth or parts of the character that is not essentially organic, it's not part of the body, maybe antennas and things like that. So flash forward 20 minutes later, and I thought it could be fun to demonstrate this use of bone parenting. Basically here what you're seeing is a model that is using the mixamo motion capture data, but it's actually not using a normal regular skeleton, like a skin mesh rendered auto rigged with mixamo. What did I do here? How did I manage to make like a robot out of the system? Well, this is what I did. I just got a character, kind of like a normal looking character here. Sure, use this character. I downloaded it. I downloaded it in actually without an animation, but that doesn't really matter. I just downloaded it in T-pose, download FBX for Unity, whatever, T-pose, and then download. And then it looked like this, and then I got rid of the skin, basically. Let's go through the process. But yeah, Mixamo has its own system, its own particular skeleton, its own particular armature, and if it recognizes that, it means that it can animate, it can remap one of these animations to whatever you throw at it. So that's why you can just like download an animation. If you're not happy with it, you can also like repaint the weights or something like that and still apply the animation, the stock animation. So I just clear the animation data here, select the main skin and get rid of it, and you are left with a Mixamo, standard Mixamo rig armature, and it has these names. You don't want to change them, and what I did was just basically just put a bunch of boxes here, and I parented each individual boxes to each individual bone or to some of the bones, doing this sort of like tedious process of selecting a box and selecting the skeleton, selecting the bone, going to pose mode, and then selecting the bone I want to parent it, and then going to pose parent like I did a second ago. With some shortcuts, it's pretty quick. You can do that in a few minutes. It's a bit tedious. Also, it's a little bit tedious to kind of like symmetrize something that is made of different objects. You might find your own systems for doing that. But yeah, basically you want individual objects separated. you can accomplish more or less, and then yeah, so then once everything is parented, you can try in you can try in pose mode, selecting the skeleton and making sure that things are actually attached. Probably if I just grab one, if I grab the base of it and everything moves around it, moves along with it, it should be fine. And yeah, by the way, you see that if you're parenting an object, even if it's kind of like just randomly positioned, it will always maintain the relative position of your bone. So it will kind of like maintain the same distance and inherits the rotation essentially. And then you select everything, you export as, it has to be exported as FBX. I called it Boxman. In this case, there's nothing else in the scene, so I can select everything. And then you can import, you can upload the character from your hard drive. So it will take a while to think about it, and then it will be a Mixamo compatible character. All right, this is all I have for now. Here's my Boxman back there, and then I can just go to animation and assign all the animations. And then I can re-download it, and it will come, downloaded with the animation mapped to that skeleton. All right.